more momentum. Let's go back to our cannon. If we have a cannon of mass 1,750 kilograms firing a shell of mass 15 kilograms, and the velocity of the shell is 80 meters per second, what's the recoil velocity of the cannon? So if the shell goes in one direction, the cannon recoils in the opposite direction, but at what velocity? Now remember, momentum is conserved. So if you work out what is the momentum of the shell, then the total momentum of the cannon in recoil must be the same. What is that? So here's the answer. You'll have to turn yourself upside down to read it. But remember, first of all, calculate the momentum of the shell, and then the momentum of the recoiling cannon must be the same, but in the opposite direction. Let's go back to collisions. If you've got a 1,500 kilogram vehicle travelling at 9 meters per second, and it goes into the back of a stationary 1,000 kilogram vehicle, the larger vehicle continues at 1 meter per second after the collision. I'd like you to calculate the momentum of the larger vehicle before and after the collision, and then calculate the momentum and velocity of the smaller vehicle before and after the collision. Remember, total momentum is conserved. Pause the video while you think that through. Again, you'll have to stand on your head to read this unless you've printed it off, but work it out on your own first and then check your answers. Impact forces. Now, these are the forces involved in a collision, and the force of the impact depends upon the mass of the vehicles, upon their change in velocity, and upon the duration of the impact. How long does the impact take? Because the longer the impact time, the more the force is decreased, because the momentum of the colliding vehicles is lost over a longer period, and therefore the kinetic energy is transferred over a longer period. So how do you calculate the impact force? Now, this again has to be done in two stages. Firstly, you have to calculate the acceleration. Now this is going to be negative acceleration because it's colliding vehicles, they're going to be stopping. So don't forget to give it a minus sign. So remember this triangle, the change in velocity over acceleration times time taken. What we're after is the acceleration, and it's going to be a negative sign. And secondly, once we've got A, we can then calculate the force, FMA, this triangle here. To calculate the force, you need to carry out a step first. You've got to calculate the acceleration. So the acceleration from the first calculation is needed for the second one. So here's an example, see if you can work this out. A car of mass 1,000 kilograms travelling at 10 meters per second crashes into a wall. The impact time is 0.5 seconds. So calculate the deceleration, in other words the acceleration, but give it a minus sign, and the impact force. Pause the video while you think that through. So here's the answer. Calculate the acceleration first, and then use your answer from that to then calculate the force.